have come again once again. What am I holding? And it is gearbox system. You can find it on washing machine gearbox. It is what through the bucket. They call it bucket in a washing machine. You put it cross. So here is drive by induction motor about 300 watts, 500 watts. So this is a planetary gearbox gear system, gear reducer. So it is a gear reducer. I find it interesting. So how portable and design it is. So it is a ratio 1 to 5. So it is a ratio 1 to 5, which means if the driving speed, assuming if the driving speed here is 5,000 rpm, assuming if the driving speed here is 5,000 rpm, the output rpm will be 1,000 rpm. Assuming if the driving speed here is 100 rpm, what you see here is a 10 rpm. So it is 1 to 5, ratio 1 to 5. Then if you turn it around this way, if we drive 10 rpm here, the output here will be 100 rpm. If we drive 1000 here, the rpm here will be 5000 rpm. So it is the other way around, opposite. So if you hook your motor here, assuming your motor is running on low speed, then you want to increase the speed times 5. It is like times 5. Then when the motor run 100 rpm here, the output here will be 500 rpm. When the motor run 100 rpm here, you can see by turning it small rotation, the speed here increase. You can see. So by when you turn it around here, assuming you hook your motor here, if your motor turns faster speed, the speed here will reduce. But assuming assuming you have a motor and the speed, let's assuming the speed is 1000 rpm, you hook it up here and you want to reduce it, assuming the motor is 1 newton meter by torque, 1 newton meter by torque. Then you hook it up here. Then what the output torque here will be 5 newton meter. Remember the input speed is 5000. Assuming the input speed is 5000 rpm, then your motor is 1 newton meter. Or let's assume your input speed here is 500 rpm, 500 rpm. Then your motor torque is 1 newton meter. Remember 500 rpm, 1 newton meter. What we have here is 100 rpm output and 5 newton meter. You have already increased the torque by, even if you put your hand, you will be very, assuming you can easily hold it from your shaft from here. You cannot easily hold it from here because the torque has increased massively times 5. That is why it is ratio 1 to 5. So and this gearbox is a planetary gearbox. It's not a warm gearbox. It is a planetary, and which is one of uh, best gear ratio and best gear design planetary gear system. You can see. So I'm gonna lose it. So guys, I'm gonna lose it from here. Okay, I'm gonna lose from here. Turning it from this side is very very hard, very very hard because it is a torque side. Turning it from here is very very hard. And you see my small spinning trigger faster spinning here. You can see. Then turning it from this side is simple. It's very very easy. You see, it's very very easy to turn the shaft, rotate the shaft. So now I'm gonna dismantle it with my screwdriver. So you can see the mechanism, a pour a grease, so there will be much friction. So now you guys will see how they structure everything. So this one here goes in. Then when you turn these four small small this thing rotates around, then the this shaft here is the torque side. So this is how it goes, clockwise, anti-clockwise, will rotate. So this is the gearbox. This is the only shaft connection that leads to the output. So this gearbox can be found on a washing machine. It can be found on washing machine. So let me couple it back. So when couple it back, this dot here have to enter here. So for easy coupling, you can see near the shaft. Just lap. So let me tighten it back. So it is a planetary gear system, one of the efficient uh, gear system, planetary gear. See? So now there are another thing I want to display here. Um, some people we ask how do I know it is a ratio 1 to 5 or 5 to 1. So it is simple to detect without checking the label. It's easy to detect. Now, what will you do to know any gear system, any gearbox system, to know the ratio? It's very simple. Okay, now this is it. My tape here now. What am I going to do now? So I have to come out small. I have to remove small pieces. Now I have to place it this way. I have to place it on this side. This four corner. So I have to place it this way. That's it. Then I have to press on the driving gear. Driver gear. I have to shout. So I have to press it so that it will be opposite. So that it will be opposite. So now I have to remove small pieces of the tape again. So now I have to make it careful. So now I have, I have pasted it. So they are the same in opposite. So now what am I going to do now? Then I will rotate this driving gear shaft. Then we will know how many revolution per minute before we will have this side. I placed a tape opposite, yeah, upside. Okay, now 1, 2, 3, 4, 5. Now you have seen it. So when we rotate this shaft uh, 5 times, this one will rotate one time, only one times. When we rotate this side 5 times, this one will rotate once, only once. Let's do it again. 1, 2, 3, 4, 5. Okay, when we turn it around, now when we rotate this side once, this one will run 5 times. Now let's carry the results. From there, it has already counted 1, 2, 3, 4, 5. I've seen it. So this is how to determine the shaft, any gear system ratio without checking the label. Assuming the label has worn out any gear system, this is how you will know the ratio by position something like tape or any mark. You can use a mark to indicate it, then indicate the other shaft, then carefully observe it by rotating the shaft. Then this will give you the gear system ratio. So this gear system, you can find it on, I would say it several times, you can find it on washing machine, and you can use it some for various projects. If you want speed, you attach the motor here, then you get your speed 5 times. But remember, the torque will be reduced. But when you attach it from here, the speed will reduce but the torque will increase. Thank you for watching.